Okay guys, 8.7 and the last part of this chapter deals with modeling with exponential and power functions. We're starting with exponentials, which look like y equals ab to the x power, okay? And they're telling us find the model of this function if this function goes through the point 1 and 6 and 3 and 24. Remember, we call this an x and this an y, and this an x and this an y, right? That's every point has two coordinates. We're just going to take and replace them in. So this becomes 6 equals a times b to the first power, or b, right? My second equation is 24 equals a times b to the third power. This is my y, this is my x. And the only way to solve this is to substitute. I can pull my 8 out of here by dividing the b out. And I end up with a equals 6 divided by b. And I can take this now and replace it in here. It will work like this all the time, right? So this becomes 24 equals a, or 6 over b, times b to the third. Well, remember, this is basically, this goes out and this becomes to the second power. You get 24 equals 6b to the second. I divide my 6, 4 equals b to the second. B equals what? Does anybody can tell me? 2. So I have my b, which means now I can go ahead and get my a. My a is 6 over 2 or 3, which means really my function is y equals 3 times 2 to the x. Once I get my a and my b, I just plug them in there and I get my function out. So remember, every time you have 2 points, you plug them in here. For the smallest one, the one that's easiest to work out, you're going to isolate a, or just find a, and then you're going to replace it into this one. It's a substitution theory we did in system of equations. Get your b out, take it right back in here, and get your a out, and then you just replace it in your function. They're pretty easy, and the homework I handpicked to where it's not going to be that hard. For the second part, once we learn how to find whatever functions we're looking for, is the part where we learn how to model with them and get them out of the calculator. On example 2, it talks about millions of cell phone subscribers, and they want to know, first of all, is this a exponential function? The first part in your book is asking you to do that by hand, and we talked this in class. You will never do that. If you look on the example 3, it's using example 2 using a calculator. We will always use a calculator, so you're skipping a big part of it. You don't ever have to do a scatter plot. Read your homework with care. If they're asking for a scatter plot, you don't need one. You're just going to do it the way we did it in class in the calculator. And if you look at the top of 510, you have a table. This is the old school stats. You have a paper for it. You're going to go to stats. We're going to go to edit. And I put in my L1, I'm putting 1 through 10, or my first column. On L2, I'm putting the 1.6 through 48.7. My second column, I have my L1, I have my L2. I now need to get the model out. We're going to go back to stats. We're going to go over to calc. So far, we used 4, 5, and 6. We used the linreg, the quadleg, and the cubic reg. If you keep going down on that thing, you get to the 0 part, or the 0 thing, and that is exp reg, exponent reg, and that's the one we want to use. And it's asking me, do you want me to use list 1 and list 2? Yes, I do. I'm going to hit 3 zeros, and here is my answer for my beautiful function. This becomes, here's what the calculator gives me: y equals a times bx, where a is 1.3, and I'm just going to use 3 decimals, so I'm not 0, 0, so I don't care about that, and b is 1.46. So my function is y equals 1.3 times, parenthesis, 1.46 to the x power, and that's it. This is probably one of the easiest things you're going to have to do. It's just time consuming to put your numbers in. Make sure you put them correctly, but that is your answer. If you look in the book, it's the exact same answer. So we're skipping all of that work by hand to go bananas on it, and we're just going to use stats, edit, put the 2 list in L1, L2, go back to stats calc, and go all the way down to 0, which has exp reg. Use that, and it's going to give you what you need. In our case, that's my model. We are good to go. If you ever doubt and you go, is this really an exponential function? You can now go 1.3, go to the y equals, and put it in, and graph it. I just plugged it in here. And now I'm going to go zoom 6. I'm pretty sure I can see it. And yes, believe it or not, it is an exponential function. It's an exponential graph, right? If you ever feel like, I'm not sure about this, I want to make sure that I got it right, graph it. And if it looks like this, then you're good to go. Or even if it looks like this, because if your A is negative, it's going to point down, okay? The second type of modeling we did in this chapter is the power functions. And the power functions looks like y equals a times x to a power. And it's telling us we need to find this power function that goes through 2 and 5 and 6 and 9. Again, remember, this is an x, this is a y, this is an x, and this is a y. So we can go ahead and replace them. My first one is 5 equals a times 2 to the b. My second one is 9 equals a times 2, no, times 6 to the b. And again, I'm always going to use the smaller one just because you can. You can do it either way, but this is the easiest one to do it. I'm going to go ahead and divide this by 2 to the b power in both places, which means this is gone. I can go ahead and erase it. And I end up with a equals 5 over 2 to the b. And now I can take this and place it in here. 9 equals a, which is 5 over 2 to the b, times 6 to the b. And this is the part that we said it can be very confusing, but we're going to work at it. Anytime you put it over 1, this becomes 5 times 6 to the b over 2 to the b. And if you remember from the long lost exponential rules, if they have the same exponent, I can write this as 5 times 6 over 2 all to the b. Why am I doing this? Because I need this reduced, right? They have the same exponent. I can combine them. This becomes 9 equals 5 times 3 to the b. Okay? Now I can divide the 5 out, which means 3 to the b equals, I don't know what 9 divided by 5 is, but I'm going to find out right now. It is 1.8. And now I'm stuck because 3 and 1.8 cannot get the same base, which means the only thing that I can do is take the logarithms. And I'm going to take the base of that. It's going to be log 3 of 3 to the b. Because they need to repeat. And this is going to be log 3 of 1.8. What I do on one side, I do on the other. This is where my variable is. So this is where I'm going to do the matching. They cancel out, which means b equals log 3 of 1.8. You're going to put this in your calculator as log of 1.8 over log of 3, because we cannot do bases in there. I'm going to do it here with you. 1.8 divided by log 3. And I'm going to end up with b equals 0.535. It's an ugly number. It's okay. It doesn't matter. And I can take this b now, and I can plug it in here. My a is 5 over 2 to the 535.535. And I can just plug this in my calculator very easily. 5 divided by 2 to the 0.535. Get it out, and my a is about 3.45. So my power function is y equals a 3.45 times x to the 0.53. They're never going to look very pretty, okay? These are the ones that are going to look funky, but that is okay. This is how we got it. We get, again, isolate one variable, solve for the other one, take the log that you can get rid of that number, and then you take that b, you replace it in here and get your a. Please never forget to give me the final look of the functions, because otherwise it doesn't work. If we flip the page on 512 and the last example we're going, well, close to last, no, it is the last example we're going to do, is learning how to find the power model. And again, this is all calculator work. We are not going to use anything, sorry about that, other than the calculator. They do a different part in here. We're going to go straight to the example 6. It's the same problem. You're going to go to stats, to edit, and now for your first list, you're going to put the values for x. For your L2, you're going to put the values for y. And then we're going to go to stats, over the calc, and now we're looking for a power reg. If you give me a second, that would be your A. Right under 0, you have an A, power reg. Okay? You're going to use that one, and you're going to tell it what list to use. I already preloaded mine so I can get this done fast with you. And here is my answer for this one. Okay? Which gives me, I didn't erase the board. Give me 1 second. This is a y equals a times x to the b. My a is 1. My b is 1.5. So my function is y equals 1 times x to the 1.5, or y equals x to the 1.5. Never ever use anything by hand. Only use your calculator to find this. Remember, for the exponential, you're looking for expreg, which is option 0. For the power model, you're looking for pow-reg, which is your option A right under exponent. And that is, we are done with the whole chapter 8. Happy homework.